Hi, I'm Colin Walls, and I'm here again to talk about embedded software. Today I'm in slightly philosophical mood, and I was thinking about the world and how it's divided into two kinds of people really. There are engineers like myself, and there's all the other people who believe in magic. What do I mean by that? It's very simple that an engineer has this problem. Um, I have it, you probably have it if you're watching this video. That problem is we need to understand how things work. We're not comfortable with any technology unless we understand at least the fundamentals of how it works. Then there's everybody else who just accepts it and just uses things. In other words, they might as well be believing in magic, because if you don't know how something works, it might as well be magic. There is an interesting middle ground though, when technology is just so good that it almost looks like magic even to an engineer. I think of lots of everyday things like cell phones and GPS. I think they're pretty magic, even though I understand how they work. When we come to look at embedded software though, where does magic come into that? Well, the magical component in any embedded software engineer's toolbox, I think, is the compiler. And what does a compiler do? A compiler translates a high-level language into machine code. Actually, no, it doesn't. What a compiler does, a good compiler, an optimizing compiler as we would use today, is it translates an algorithm expressed in a high-level language like C or C++ and translates it into an algorithm which does the same job but expressed in assembly language. Let's take an example. Here is a very simple piece of code. All it's doing is we have an array of 4 bytes and we're going round a loop writing 0 into each byte. Couldn't be simpler really. Now you might expect this to compile into a loop as I've just described, with a counter counting down from 4. The reality is if you compile this with an optimizing compiler, you'll probably get something like this. Now this is pseudo assembly language, showing you that the clear of the 4 bytes can be done with more or less a single instruction, so just writing 0 into a 32-bit location. That's because the compiler was smart enough, magic enough if you like, to realize what you were trying to do and come up with a more efficient way of doing it. In fact, depending on the CPU, the code could even be simpler. In fact, I can imagine there are situations when it's simpler still. I did some research into this and I found that as you make the array bigger and bigger, the structure of the instructions gradually changes. So for example, if you had 6 bytes, you might have a 32-bit clear and then a 16-bit clear. If you've got an array of 40 bytes, then you probably have a loop, but you only go around 10 times, clearing 4 bytes at a time. So it's pretty magic, it does things in an efficient way. This leads to some interesting challenges with debug and so forth, so the general recommendation is when you're starting out doing debugging, you turn optimization off, but at least once you turn it on again, you can understand why the code appears to behave a little oddly, even if the results are correct. So that's today's magic lesson. When compilers do magic, which I think is pretty cool. I'm not a compiler writer myself, but I have big respect for those guys. That's all for today, so I hope to see you again sometime soon when I'm talking about another embedded software subject. So, bye for now.